Which property of polymethylpentene, PMP, makes it the gold standard for ECMO oxygenator fibers compared to older polypropylene? A. It is significantly cheaper to manufacture. B. It is a non-porous solid membrane that prevents plasma leakage. C. It requires a higher gas flow to function. D. It can only be used for less than 6 hours. Answer: B. It is a non-porous solid membrane that prevents plasma leakage. Explanation: PMP fibers are truly non-porous. Older polypropylene fibers were microporous, which eventually allowed plasma to wet out the membrane, causing it to fail. PMP allows for long-term support, days to weeks, without plasma leakage. During circuit assembly, what is the significance of luer lock orientation on the pressure monitoring manifolds? A. They must be left open to air to ensure gravity drainage. B. They must be tightened and positioned to prevent dead legs where air can trap. C. They are only used for the administration of heparin. D. They must be color-coded for the patient's blood type. Answer: B. They must be tightened and positioned to prevent dead legs where air can trap. Explanation: air bubbles often hide in the dead legs of stopcocks and manifolds. During assembly, these must be oriented so that priming fluid flushes through every port, ensuring no microscopic air pockets remain that could later dislodge into the patient. When performing a blood prime, which medication is typically added to the circuit to counteract the citrate used in stored bank blood? A. Heparin. B. Sodium bicarbonate. C. Calcium gluconate or calcium chloride. D. Magnesium sulfate. Answer: C. Calcium gluconate or calcium chloride. Explanation: bank blood is preserved with citrate, which chelates, binds, calcium. When a large volume of bank blood is used to prime a circuit, especially for neonates, the ionized calcium levels drop dangerously low. Calcium is added to the prime to normalize levels before the circuit is open to the patient. What is the step-down method in the context of de-airing a circuit? A. Gradually decreasing the pump RPM to see if bubbles settle. B. Lowering the height of the oxygenator below the pump. C. Sequentially clamping and releasing segments of the circuit to force air toward a vent. D. Reducing the FiO2 of the sweep gas. Answer: C. Sequentially clamping and releasing segments of the circuit to force air toward a vent. Explanation: the step-down or walk-down technique involves using a clamp to create a pressure surge that pushes air bubbles from high points or connectors down the tubing toward the bridge or the venous reservoir/vent port for removal. In a centrifugal ECMO circuit, where is the flow probe usually placed for the most accurate measurement of systemic delivery? A. On the venous drainage line before the pump. B. On the arterial return line, after the oxygenator. C. Directly on the oxygenator's gas inlet. D. Inside the pump head. Answer: B. On the arterial return line, after the oxygenator. Explanation: the flow probe, ultrasonic, is placed on the arterial, post-oxygenator, limb. This measures the actual volume of oxygenated blood being returned to the patient, ensuring that any shunts or recirculation loops are accounted for. Why is heparin often added to the priming solution even if the circuit is heparin-coated? A. To prevent the coating from peeling off. B. To provide systemic anticoagulation the moment the patient's blood hits the circuit. C. To increase the viscosity of the crystalloid. D. To act as a pH buffer. Answer: B. To provide systemic anticoagulation the moment the patient's blood hits the circuit. Explanation: while modern circuits have covalent heparin coatings, like Bioline or Carmeta, these only protect the surface. Once the patient's blood enters the large surface area of the circuit, systemic anticoagulation is needed to prevent bulk clot formation in areas of low flow. What is the consequence of leaving a bridge open during clinical VA-ECMO support? A. It improves oxygenation by doubling the gas exchange. B. It causes a shunt where blood bypasses the patient, leading to decreased systemic flow. C. It prevents the pump from overheating. D. It reduces the risk of circuit hemolysis. Answer: B. It causes a shunt where blood bypasses the patient, leading to decreased systemic flow. Explanation: If the bridge remains open during support, blood will take the path of least resistance through the bridge rather than through the patient's high-resistance systemic circulation. This effectively steals flow from the patient. During the dry leak test, the circuit is pressurized with gas to A. Test the integrity of the heat exchanger stainless steel tubes. B. Ensure the pump can reach 5,000 revolutions per minute. C. Identify any cracks in the oxygenator housing or loose connectors. D. Measure the total volume of the circuit. Answer: C. Identify any cracks in the oxygenator housing or loose connectors. Explanation: pressurizing the dry circuit with gas, and sometimes submerging connectors in sterile water or using a pressure gauge, allows the specialist to find leaks before they become a wet mess or a source of air entrainment. What is the recommended sweep gas setting during the priming phase? A. 10 liters per minute of 100% O2. B. 0 liters per minute, off. C. 2 liters per minute of room air. D. 5 liters per minute of CO2. Answer: B. 0 liters per minute, off. Explanation: during the liquid priming/de-airing phase, the sweep gas should generally be off. If gas is flowing through the oxygenator while it is being filled with liquid, it can actually promote the formation of microbubbles across the membrane. Which of these is a mandatory final check before connecting the ECMO circuit to the patient's cannulae? A. Ensuring the prime is warmed to 37 circ C. B. Verifying that all air has been removed, the bubble watch. C. Confirming all stopcocks are in the correct position and capped. D. All of the above. Answer: D. All of the above. Explanation: patient safety requires that the prime is normothermic, to avoid arrhythmias, completely air-free, to avoid stroke/embolism, and that all ports are secured, to avoid exsanguination.